This presentation is on understanding what is happening in the Goldmines investigation. I've created a manipulative scenario to help you visualize what is happening. And you can see down here on this part of the graph, looks very similar to what you were given in the problem, where there's point A and B, which are different gold mines, and a pump P, which is placed somewhere in between these points that are vertically below A and B, and these points C and D were where another pipeline would pass through and direct water from P out to these points. And one of the things that we're investigating is how are you going to be able to minimize the distance from A to P and from P to B in order to reduce cost. And you can see that what I've done here is I've created this so I can move P, and you can see what happens to this distance from C to P here. Right now it's at 5. And you can also see that I've called this distance D 8, which is from C to D. And the project refers to X as this, because this is changing. And then D becomes another variable later on, and we'll look at that in just a moment. But you can see what's happening here is as I change this distance gets shorter or longer, and this distance gets shorter and longer, but also these distances A to P and P to B change. And so if we move them, we can see that the distances will not always be the same. There is a shortest distance. So if we look up here, this number is going to change based on how I move this. And this number is the distance from A to P to B, the total distance of pipeline here. So you see here, it's at 2, it's 12.07 kilometers, and as you move it, it goes down and then hits a minimum point and then starts coming back up. So that's one of the things you're looking at, is this idea of a minimum. It's not a parabola, by the way. Some of you have used the word parabola in your investigation so far, and it's not a parabola. So if I take a look here, and I've created a point E, and this point is going to represent the total distance of AP and PB as I move P closer or further away from C. So let's see what happens here. Right now, well, if we move it here, let's say where CP is 5, we can see that E is also at 5, but also E is just a little bit below 11.5. So again, 11.5 would be the distance of the pipeline here. And you can see E moves and gets higher here as I move closer and closer, and again comes back down if I go this way, reaches a minimum and comes back up. Now, the idea is that this path of E is described by the graph that you do in question 5, which is this graph right here. And you'll notice, look what happens. As I move P, it hits a minimum point and then comes back up. Okay, so that's a little bit to help you understand how the varying of the distance CP will change the total distance of the pipeline AP and PB. Now, the next part of it asks you to consider other lengths of C to D. So I've got this here where I can vary that, and I want you to watch what happens to the graph. As I move D further away from the origin, you can see that the graph moves up. Why does this make sense? Well, because you're going to need more pipeline here to go from A to P to B. And so, therefore, the graph is moving up. In other words, the amount of pipeline needed is increasing. And you can see that if I have a larger distance, would go all the way up here. But let's look at 10. And again, just as before, if I move this, you can see that point E moves along the trajectory of that graph. Now, you'll also notice that it reaches a minimum point at a different place, which also makes sense because we've changed this distance d. So your job is going to be to find these minimum points. Using autograph is the easiest way. Some of you have chosen other methods, but really, autograph is the easiest way to do this. And then to look for some sort of pattern by filling out the table in question 7. So good luck with that, and I hope this has helped you make sense of the Goldmines scenario.